All right, so from our notes, today we're going to be looking at questions 25 through 32. So we're still looking at exponential equation. So you guys see in the notes coming up later, we're going to learn even how to graph these. Now, interesting part of this is given two terms, right? Questions number 25 and through 28. I'm giving you guys two terms. Find the common ratio, right? So find the ratio. The numbers can be consecutive. What I mean consecutive is one right after the other. Notice how number 25, I gave you the fifth number on the list. I gave you the sixth number on the list. So there can be consecutive, but sometimes they're not. Looking at number 26, there's a gap in between them. Right? I give you the first number and the fourth number. So they're not quite consecutive all the time. When they're consecutive, it's a little bit easier than when they're not. The way I'm gonna do this, I'm gonna start by multiplying this. I'm gonna start by writing the smallest number. So negative 512. And what I mean the smallest number is like the fifth number or the sixth number, right? The number that comes first. So I'm gonna say negative 512. I know I have to multiply this ratio, right? The first number, I'm gonna have to multiply this by the ratio. I don't know what the ratio is. So for right now, let me just call it R. That's basically what I'm solving for. And I have to multiply the R one time. And this is going to equal to 2048, all right, 2048. The way I knew that I had to multiply the ratio only once is because I have the fifth numbered, I have the sixth numbered, subtract those two subscripts, right? 6 minus 5. And that's how I got the exponent of my R. Again, subtract those two numbers, and that's how you get the exponent of the R. All right. Now, to get the R by itself, we learned back in the days that we do opposite operations, right? To get the R by itself, let me divide by a negative 512. So I'm going to say that R to the 1. Right now, let me leave it as R to the 1 is equal to, I have, let me use my calculator, 2048 divided by a negative 512, and it gives me negative 4. R to the 1, but R to the 1 is basically R. So I have that R, it's equal to negative 4. My ratio is negative 4. For my answer, I don't have to type R equals, just R equals negative 4, just negative 4. The ratio is negative 4. Now, when they're not quite together, I gave you guys the first number on the list, the fourth number on the list. So I'm going to say negative 1 times the ratio 3 times is equal to negative 27. Right, I had to multiply the ratio 3 times. And again, the way I came out with the 3, I see my subscripts. The first number, the fourth numbered, I subtract those two values, right? 4 minus 1. That's how I knew I had to multiply my ratio 3 times. All right, so let me start by dividing by a negative 1. So I get that my ratio to the third power is equal to positive 27. Right? Negative divided by negative is positive. So ratio to the third power is equal to positive 27. Now I'm finding the ratio, not ratio to the third power. Now we know that addition and subtraction, they undo each other. Multiplication and division, they undo each other. The opposite of an exponent is a root. In this case, I'm going to do the cube root. I'm thinking which number multiplied by itself 3 times gives me 27. And I'm just going to say R is equal to 3. Right? The cube root of 27 is 3. You can use a calculator. Make sure you know how to type that in. If you need questions, let me know. I can help you how to type it in. So R is equal to 3. The ratio is 3. Now let's take a look at question number 27. I have the first number in the list. I have the second number in the list. So the first number comes first. So I'm just going to say -1 times the ratio to the 1 is equal to 3. And the exponent on the ratio, again, I subtracted my subscripts, and that's what gives me the exponent on the ratio. Now let me divide both sides by a -1. So I have that R to the 1 is equal to -3. R to the 1 is basically R. So R is equal to -3. Right? When my numbers are consecutive, the numbers I give you in the list, they're consecutive, simple. You're going to post this. I have a question because my screen is lagging. Yes, I will be posting this as soon as we finish the lecture. When the numbers are consecutive, so the number right after the other, the ratio is kind of simple. When the numbers are not consecutive, again, I'm looking at question number 28. The numbers are not consecutive. The ratios, I have to do one more step. I have to use radicals. I have to use roots. So here I gave you the first number. I gave you the sixth number. So then I'm going to say -2 multiplied times the ratio 5 times is equal to -486. Remember the first number, the sixth number, you subtract those subscripts. That's how I got the exponent of the ratio. That's how I got the 5 from the R. All right, let me divide both sides. Let me divide them by a -2. So then I got the R to the 5th, the ratio multiplied 5 times is equal to, then I have to go 486, well, -486 divided by -2. The negatives cancel out. So I have 243. Okay, R to the 5th, not R. The ratio to the 5th power is 243. And I said earlier, the way you're going to undo an exponent, right? The opposite of exponent is it's a root. In this case, it's a 5th root. So I'm going to say the ratio is the 5th root of 243. And I'm going to type that in. I'm going to say to the 243, the 5th root of that is 3. Again, make sure you know how to type it in on a calculator. I can help you if you don't know how to type it in. That's how we find the ratio. That's how we find the ratio given any two numbers. So that's what I did. I just gave you any two numbers. So here I have a question. So if it is over 1, it becomes a square root. It becomes when it's the exponent is 1, then that's R, right? Because R to the 1 is just R. When the exponent is not a 1, like in the number 26, my exponent was a 3. Number 28, when my exponent was a 5. When it is not a 1, it becomes a root. Not a square root, because it could be a 3rd root. It could be a 5th root. It becomes roots. Make sure you know how to type that in on your calculator. Okay, good. Now let's take a look at number 29. I'm going to give you two terms, right? They don't have to be quite consecutive. In this case, I gave you the 6th term, the first term. So given two terms in the geometric sequence, find the term naming the problem. So I gave you the 6th term, the 6th numbered. I gave you the first numbered. And I want you to give me the 11th number. Okay, so let's see. Let's find out. The way I'm going to do this, I'm going to find the ratio first. And I'm going to say 1 times. I always start with the first number from the list, right? The smallest number. I gave you the 6th numbered. I gave you the first number in the list. First comes before 6. So I'm going to use the ace of 1. So 1 times, I'm going to say that ratio to the fifth place is equal to negative 243. Let me emphasize that this is ace of 1 and this is ace of 6. Right? Ace of 1 comes before ace of 6. So that's the first number. That's the sixth number. So I think we can agree that r to the fifth is equal to negative 243. All right, so let me do the fifth root on each. All right, r is the fifth root of a negative 243. I typed that on my calculator. Which I have a negative 3. So I have the ratio. The smaller number always comes first out of the question? Yes. The first number from the list, like the one that comes first on the list. All right, so I found my ratio is negative 3. The question was not find the ratio. The question is find the 11th number. Now, to be honest, I'm going to use that from the two numbers that were given, the sixth number, the first numbered, I'm going to use either one. It doesn't matter which one. Just to choose one, and because it's easier to deal with, I'm going to choose the first number from the list. And then I'm going to go, the way I'm going to write this will be the 1, which is that number, times my ratio, 10 times, is going to give me the number that I'm looking for. Let me call this ace of 11. Now, how did I come out with the 10th? I subtracted my subscripts. And I subtracted my subscripts. That's how I came out with the 10. If I would have used the 6th number instead, my exponent on the r would have been 5. Again, I subtract the subscripts. All right, let me figure out my exponent first. So I have the 1 times negative 3 to the 10th power. Right, negative 3 to the, multiplied by itself 10 times. Use a calculator. So 3 to the 10th gives me 59,049. And again, that's the number that I'm looking for. Let me call it ace of 11. Now, 1 times 59,049 gives me 59,049. So a couple of things we have to do. First, find the ratio. Right? You use the two numbers given to find the ratio. Notice that's exactly what I did here. I found the ratio. Once I get the ratio, use it to find the number we're looking for. All right, let's take a look at a few more examples. Question number 30 in our notes. I gave you the 6th number in the list. I gave you the 3rd number from the list. So I'm gonna say negative 9 times r to the 3rd is equal to negative 243. Right, the 3rd number from the list comes before the 6th number, so that's why I start with negative 9. And the power of my ratio, remember I subtracted my subscripts 6 and 3. All right, to get the r by itself, let me divide both sides. Let me divide it by negative 9. So I have that r to the 3rd. The cool thing is that negative divided by negative is positive. 243 divided by 9 is 27. So I'm going to say that r is the cube root of 27, which is 3. Nice. I found the ratio. Now I'm going to use it. I can use the 6th number on the list, or I could use the 3rd number from the list. It doesn't matter which one. Just to choose one, I'm going to choose my smaller number because it's a little bit easier to deal with. So I'm going to say negative 9 times r to the 9th. Remember, I'm looking at my subscripts, 12 and 3. I subtract those values to come up with the exponent of my ratio. And this is ace to the 12th. This is the number that I'm looking for. So I have -9. I had to multiply this times 3 to the 9th. So let me find out what the exponent is first. What's 3 to the 9th? Now 3 to the 9th happens to be 19,683. So I have -9 times 19,683. When I multiply these two, I get -177,147. The comma between the thousands and the hundreds, optional. I wrote it, but it is optional. Again, make sure you get the ratio first and then use it. Let me take a look at a couple more questions. Let me flip our page. Let's take a look at question number 31. I'm going to find our ratio first. And I'm going to go 9 times our ratio to the third power is equal to 243. I know 243 divided by 9 because I have to divide both sides by 9. R to the third is 27. So I know that R, our ratio, is the cube root of 27, which is 3. Nice. So I found the ratio. The ratio was 3. Now I'm going to use it. Let's see. I have the third number from the list. I have the sixth number from the list. I've been choosing the small number, but I don't have to. I could choose any number from the list. This time, let me choose the sixth number. So I'm going to say 243 times 3 to the 6 is equal to a of 12, the number that I'm looking for. Let me emphasize a couple of things. This 3, that's my ratio. By my ratio, the number I keep on multiplying over and over is 3. And then my 6, my subscript. Remember, I subtracted these two given. All right, so now let me work this out. I have 243, that's my first number. That's fine. Now 3 to the 6, I have to figure out what's 3 to the 6. 3 to the 6 is 729. When I multiply those two numbers, let me just say this is the 12th number on the list. So when I multiply these two numbers, I get 177,147. This is the 12th number on the list. Interesting. Take a look at one more example. The way I'm going to find the ratio, I'm going to use the numbers given. So I'm going to say 2 times the ratio is equal to 4. My exponent of R is just the 1 this time, because when I subtract my subscripts, I get a 1. All right, let me divide by 2. So I get that R is equal to 2. Cool, I have my ratio. Now I have the second number on the list. I have the third number on the list, and I'm supposed to find the 11th number on the list. All right, from the two numbers given, the second number or the third number, use either one. Again, to emphasize that it doesn't have to be the small number, I'm going to choose the bigger number. So 4 times 2 to the 8th is equal to 11, the 11th number on the list. The way I came out with the 8, because I subtracted my subscript, right? 11 minus 3. Let me find out what's 2 to the 8. 2 to the 8 is equal to 256. So I have 4 times 256. This is the 11th number from the list. When I multiply my numbers, I get 1,024. And my 4th number from the list is 1,024. Let me zoom out. Let me zoom out so you guys can take a screenshot. You guys can see what we worked today. Let me take roll really quick. So that's what we did today.